right, everyone. I am here with Ville Tuulos. Ville is the CEO and co-founder of Outerbounds and a friend of the show. We first spoke back in December of 2019. Ville, welcome back to the TWiML AI podcast.
Thank you. Thank you. Thanks for having me again, Sam.
I'm looking forward to digging into this conversation. Among other things, you've just got a lot of new stuff going on. New startup. Last time we spoke, you were at Netflix. You've got a book that you're working on. I'll have you tell it, but sounds like you're quite the busy guy.
Yeah, well, I mean, not the smartest idea. So maybe I can start with the book. So yeah, indeed. I mean, we spoke for the first time in 2019, like when I was still at Netflix, leading the machine learning infrastructure team. Maybe some of your listeners, like I don't know if they remember the episode, but we talked about Metaflow, which is the open source framework for machine learning infrastructure that we had started developing. And whenever I spoke about overall like how Netflix does machine learning, how Netflix does data science at different conferences and so forth, it always felt that there was never enough time to kind of really dig deep into details. I mean, because of course, I mean, this is a complex field. There are many kind of important topics. So I thought that, well, it would be fun to write a book and like, so would have enough like pages to cover like all the different topics in detail. And well, yeah, I think that that's really happening at the same time. It's a crazy amount of work. I should have known that like when I started, but yeah, no, that's going well. And like, hopefully the book will be out like early next year.
Awesome. Just to rewind a bit so folks get to know a little bit about your background. It's been a bit since we spoke last time. How'd you get into all of this data science and ML infrastructure stuff?
Yeah, good question. Well, embarrassingly enough, I've been kind of doing this like for a long time. I joined my first neural network startup early 2000s, and ever since then, I've been building infrastructure like for scientists, for researchers, like who want to build bleeding edge models and like help their businesses with machine learning and data science. And now when I joined Netflix had this interesting situation that obviously they had been doing recommendations for a long time. Many people know the recommendation systems that like give you the TV shows and movies when you log into netflix.com. But not so many people realize that Netflix actually applies machine learning to many other use cases as well, like all the way, like kind of starting from the production of these TV shows and movies. And now there are many different applications for data science and machine learning. And my team was helping all the scientists who were building different applications. Some like were using deep learning, others were using classical statistics, others were doing things that are technically not even machine learning, like operations research. And always the question was that how do we help scientists? How do we make them productive as they are building these applications, and how do we help them to actually test these like as close to production as possible? So that's like what I was doing at Netflix. And so it happened that of course many other companies are like trying to figure this out and like have been trying to figure this out like for the past couple of years. So we open sourced the package, and like now continuing that journey like with the new startups.
So Outer Bounds is focused on commercializing Metaflow, the work you started at
Yeah,
Netflix.
yeah, like or like kind of the big theme overall that like how do we help data scientists, machine learning people at different companies in actually like helping their companies how to become productive, and of course Metaflow is a big part of that story.
hmm hmm Uh, why don't we start with digging into Metaflow? What's the main problem that Metaflow is trying to solve, and how does it differ from what's now become an explosion of MLOps tools and products?
Yeah, no, it's actually like really interesting that of course now there's indeed this like a Cambrian explosion of different startups tools like approaching this whole industry like from different angles. Back when we started in 2009, sorry, I mean 2017, this was before SageMaker, this was before MLflow, this was before Kubeflow, but the problem space was still the same. So what was the situation at Netflix at the time? And I believe that this resonates with many other companies as well, that there was plenty of existing infrastructure. So you had a compute layer, so you could actually run containers at scale in the cloud. You had a data warehouse, maybe like a S3 or like a cloud-based data lake. On the other hand, like you may have had some orchestration systems that allow you to kind of run these DAGs at scale. And like maybe you had some kind of like a versioning systems, at least for the code. But now what we recognized is that stitching these systems together to build end-to-end ML applications was really, really hard, especially for data scientists who are not software engineers and like maybe not distributed systems engineers by training. So the idea of Metaflow, like since the very beginning, is that like, can we take all these existing pieces of infrastructure and like really like think about the stack systematically, like all the way starting from data, compute, orchestration, versioning, and so forth, and then like wrap it in a kind of very user friendly package, like really quite concretely a Python library, so that people who mainly have been using, let's say, Jupyter notebooks in the past are actually able to build applications that are more production ready. And of course, at Netflix, as with many other companies, the old model used to be that you had maybe a data scientist who maybe prototyped something in a notebook, and maybe a different machine learning engineer who then like took the model and kind of rewrote the model maybe in another language to make it more production ready. And even at Netflix, as the kind of demands for like a kind of a speeding up the iterations grew, I mean, it was obvious that like, well, I mean, we can't just have that model like where one person like writes one version and then it has to be rewritten for production. And the idea was that, okay, could we have a system that allows these data scientists to build more or less production ready pipelines like from the get go? And that's kind of like what we have been trying to do. And like it was really quite successful at Netflix. And now, I mean, as open source, I mean, like other companies have found it useful as well. So I mean, like trying to make sure that like it really works for different companies outside Netflix now.
What are some examples of some other users that are using it now?
Yeah, if you look at the GitHub repo, or like if you come to our Slack channel, like you will see many familiar names like the Zillow real estate company, 23andMe, of course, like in bioinformatics. Like we have actually like a good number of drone companies who build like a drones to computer really interesting computer vision. CNN like recently blogged about like how they increase the productivity of their data science organization with Metaflow. So usually the pattern is always the same, that there's some engineering team, like platform team, who have recognized the need that they have to make their platform more usable for data scientists, and then they don't want to write everything from scratch. And like for them, Metaflow provides really nice baseline, kind of a foundation on which they can then like build their maybe company specific customizations. So I really do believe that machine learning comes in many different shapes and sizes. So there isn't like a one size fits all approach. So we don't claim that we have a silver bullet that solves all problems, but it's more so that
Mhm.
the foundational questions are always the same. Everybody needs data, everybody needs compute, pretty much everybody needs orchestration, versioning. So at least like we can help people with.
And is there a particular feature set or set of functionality or use case that is kind of the sweet spot or the core value proposition relative to other things that are out there?
Yeah, good question. And then now of course, there are like so many different companies and open source tools that it's actually like even for me, it's kind of hard to tell anything apart. Like everybody is like a MLOps company these days, and so forth. What we have been doing since the very beginning is really focused on the usability. I mean, really like the human centric infrastructure, knowing that ultimately it is the data scientist who kind of make or break it, and like kind of can determine the success of any project. So really focusing on that like human interface. So that has been something that like we have been doing, and I think like that's what like really draws many people to Metaflow in contrast to other solutions that instead of like really focusing on like the engineering nitty gritty and like you have to know Kubernetes and Docker and YAML and like so forth. I mean, like kind of how easy Python interface can we possibly provide, so that like people can actually like kind of get kind of things deployed to production as easily as possible.
So, what's a specific example of an API or something that you find that folks struggle to do, and Metaflow provides it for them in
Yeah,
a much easier way?
yeah. I think like my observation is that more so than any single thing, it's actually more like a death by a thousand cuts. So this is what I observed at
Mm.
Netflix as well. That when you have a data scientist and the data scientist is given some business problem, that okay, so I mean, can you build in like a predictor for churn? Like, can we predict like kind of how long people are going to stay as Netflix members or something of that sorts? Well, I mean, I guess like oftentimes it all starts with data. I mean, the data scientist wants to kind of get access to data. How do you access the data? Now, for instance, Netflix is a big user of Spark. So, and like originally it was so that people had to wait for quite a bit of time to execute some like a SQL queries. to get the data they need. And like then as a kind of a like way to make that faster, like we introduced this idea of being able to access data directly from the data warehouse. So there's a custom S3 client now in Metaflow, so you can access data super fast from your data warehouse. And the next thing is that, well, you have to think that, okay, how do you run the compute? Do you have to write Docker files? And with that comes to this like a very mundane question that all these projects use some off-the-shelf libraries. Always you use TensorFlow, you use PyTorch, you use XGBoost, and the kind of the de facto solution these days is of course to write Docker files. But I mean that introduces a yet another like a small friction that, okay, you have to figure out how to do that. Well, as a way of helping with that, I mean, we have the conda decorator, so you like we kind of bake in the dependencies. You don't have to write any Docker files by hand. The next one is compute. How do you run compute at scale? So I would say that it's really like the fact that like we have really like we have worked with data scientists closely, like trying to see that like what are the day-to-day problems they have, and then like addressing them one by one, and then like packaging everything as a like a one cohesive package. Now, like the fact that we interface with different AWS services, that functions AWS batch, I mean that is certainly convenient, but I don't think that that's really kind of the kind of the core value prop, in a sense that like over time there will be other services that we interface with, but it's really kind of a like a going systematically like through all the pain points that people face, and then like trying to find solutions for them. And by the way, I mean, it's not so that like we always like try to reinvent the wheel. Oftentimes people use other services in conjunction with Metaflow. Many of our customers use weights and biases. They find it very useful for model monitoring. I mean, like we had a blog post with determined AI if you want to train large scale deep learning models. Now actually like we will have a blog post with Seldon that how you want to do how you can do model hosting using Metaflow and Seldon together. So as we know, I mean, it's a kind of a thick stack of different things, and I don't think that like anyone can solve all these pieces. But the question is that, okay, so how do you actually like kind of stitch together something that actually makes sense?
Got it. Got it. Got it. And so the book is the book focused on Metaflow and how to use it.
Yeah, well, I mean, the way I think about it is that overall, by the way, I mean, if I may take a step back, I mean, I ask myself the question that like, what's even the point of like writing technical books these days? Because there's amazing amount of information available online, and anyway, you can
Uh huh.
update things online and so forth. And
And
and I,
books get out of date so quickly.
books get out of date so quickly. I mean, that's absolutely true, and especially in a field like MLOps. I mean, it's kind of like crazy. I mean, I'm sure that what we are seeing today is very different, like what the situation will be in 5 years' time. So instead of like really focusing on like API documentation, which is really easily available online anyways, I thought that, okay, so at least we can systematically go through the stack, because I do think that there are some principles, some basic foundation that won't be changing, like the fact that you always need data. I mean, there are like a really fundamental, almost like a physical patterns how you access data. Then like you have the question of compute, and you have the question of orchestration. Now, so it happens that, of course, in my biased point of view, I mean, doing these things in Metaflow is quite easy. So I use Metaflow as an example. But now, if you wanted to apply the same principles, like let's say the Kubeflow, or like you wanted to use MLflow, or like maybe you have something homegrown, I think that like the basic patterns are definitely applicable. And I think like when I've been talking to many different people in this field, I mean, there's still a lot of confusion about like how to think about this large scale compute, like using container management systems like Kubernetes, or like how to think about this like a fast data processing in Python. How do you kind of combine Apache Arrow and NumPy and stuff like that? So all those things are covered in the book. And while Metaflow is used kind of as the reference implementation, I mean, the idea is that like it should be quite easy to apply them to other frameworks as well if you wish.
And so when you talk about the compute layer, to what extent does Kubernetes figure into the picture, both in the book and practically when you're deploying with Metaflow? I forget the answer to this question. I remember Metaflow not necessarily being closely coupled with Kubernetes, but I could be off on that.
Yeah, that's an interesting question. So now Kubernetes is a complex beast. I guess like everybody
It is.
agrees, and that at the same time, it seems that it's here to stay, and it does actually solve like many like a very like a foundational questions for many companies. And of course, many
Hmm.
companies have found it quite useful in orchestrating microservices. So you have, I mean, nothing to do with machine learning, but I mean, just that like you want to keep your company's product running, you have multiple microservices, you have to deploy them somewhere. Kubernetes provides exactly the right primitives. And of course, what's even more, you have the whole ecosystem of tools available on top of Kubernetes. So you know how to deploy
Right.
applications using Helm, like you can monitor stuff. So many good things about that ecosystem overall. Definitely the big downside is the complexity. So now
Hmm.
the situation, like what I've been seeing at many companies, is that you have an engineering team, and the engineering team has decided that okay, they want to go with Kubernetes because it just makes sense, like in technical point of view. Now you have a data science team, and the data science teams goes to the engineering team asking that okay, so we need to write these applications, we need to get stuff running, and then the engineering team is that okay, we have this Kubernetes thing that like you can use this, and then the data scientists start scratching their head that okay, so I mean you go to kubernetes.io and like you read about pods and you read about stuff, and you're that oh my gosh, I mean there's like 100 miles between my machine learning concerns and Kubernetes. And that's of course like where things like Kubeflow come into picture, that like you need some kind of a data science layer on top of Kubernetes. And I think that idea makes a ton of sense. Now, the thing about Kubernetes is also that it's a very amorphous thing. There isn't a single Kubernetes. There are different ways of running Kubernetes. So what we have been trying to do now with Metaflow is to really like I think two aspects. I mean, one is that if you want to run batch jobs at scale and you want to use Kubernetes as the underlying compute layer, like how does that work? So how does it work with like fault tolerance? How does it work with auto scaling? How does it work with the monitoring these workloads? And luckily, we had experience like with this from Netflix. That Netflix actually has another system called TWiML that's open source as well. I mean, it predates Kubernetes, and now Netflix has been also like starting to look more deeply into Kubernetes. But at least when it comes to running really these large fleets of containers at scale, like we had experience of that, and like we started making those experiences into the new Kubernetes decorator that we have been building in Metaflow, and that will be going out in a few weeks' time. So that's coming soon. Also, I do see that it's kind of a beginning of a journey. I don't think that like anything related to Kubernetes is ever done. So it's of
Yeah.
course also an evolving landscape there. But and there are other things like Argo. I mean, let's say you want to do orchestration on top of Kubernetes, something like Argo might be a good solution. But at the same time, I mean, there are many other systems that are really like trying to figure out their Kubernetes story. And I'm sure that like over the next couple of years, we will even see a richer ecosystem of applications.
It sounds like the summary there was when Metaflow was at Netflix, you didn't need Kubernetes because you had your own thing. And now that you're out talking to other non Netflix organizations, Kubernetes has become a requirement to some degree.
Yeah, I think that that's one way of like putting it. Also, another kind of very practical reason is that we interface directly like with number of AWS services, and I honestly think that like for many companies, just using AWS Batch, AWS Dev Functions, it's the easiest approach, and like there's absolutely nothing wrong with that. I mean, like you don't do anything wrong if you don't use Kubernetes. But at the same time, now companies who already use Kubernetes and like maybe use Kubernetes on Azure or like Google, I mean, then it's of course an interesting question that like how do we ease their path into using Metaflow, and Kubernetes can help there.
Yeah. There's an interesting discussion about kind of ways of achieving scale and different layers of cloud services that can be applied towards achieving scale for deployed machine learning models in the book. And you talk about services like batch and step functions and lambdas. Like, how complete are those services and allowing someone to deliver a production ML system today?
I mean, and I think honestly, I mean, this has been the situation already, like maybe for the past 5 years or so, that I think that like more or less everything is technically possible, but historically nothing has been easy enough. So, so if you want to, if you are really determined to get anything done, I mean, look, I used to work at this ad tech company, and like we were building this massive scale machine learning system that provided low latency
Uh-huh.
predictions. Like we had less than 100 milliseconds to provide predictions. It had to provide like hundreds of thousands requests per second, and like that system, I mean, it was like they started building it like 15 years ago, something like really like crazy time ago. So, and like of course the same story at Google, Yahoo, and like all these companies. So like it has been possible. Now the fact is that it has required an inordinate amount of effort and like a big, very talented engineers, senior engineering teams, like building this stuff like a very like a hand built like bespoke system. So, and I think that that's really like what's changing, that that now with these higher level services like batch and step functions and Argo and so forth, so like all these things become more accessible to more companies who don't have and don't want to hire like these crazy engineering teams building systems from scratch. And then also of course like the end user data scientists. So I don't think that like we are quite yet there. I think that there's work to be done. I think like, let's say, I mean, good example is serverless. I think that, let's say, for machine learning, the serverless is a great idea. That like I say that, okay, so I want to do this like a crazy hyperparameter grid search, and I want to run like 1,000 models, and like just like submit these things in the cloud, and I want the response in 2 hours. Just make it happen. I mean, that's kind of the vision, and it kind of we are getting there, but I mean, there are still like some rough edges, and I think that there's stuff that the clouds need to fix. I mean, also, I mean, Kubernetes is one component here, but I mean, I think like we are making slow and steady progress towards that vision.
Serverless, at least, as far as lambda is concerned, and a job that takes 2 hours to run don't seem necessarily
Exactly. That's, and
compatible.
like, let's say you want to use GPUs, not gonna happen. So yeah, I mean, you can't use Lambda. Then like you use, well, I mean, you can't really use Fargate. I mean, then you go with AWS Batch. I mean, it's yet another service. So there's a lot of complexity here as well.
Mhm.
And I think it's a lot of it, like much of it is actually accidental complexity. Many of these systems, including Kubernetes, were originally built, of course, like not for machine learning, not for data science. So there's kind of that impedance mismatch that you are trying to
Mhm.
use systems that were not built for machine learning workloads. And I think that like more and more systems start like treating these compute intense, data intense applications as first class citizens. So that will help over time. But I mean, as of today, I mean, like you kind of see these cracks like between the seams still. And that's of
Yeah.
course like what Metaflow is trying to do. That like, well, I mean, if you want to kind of access the future already now, I mean, you can try to kind of take a look at Metaflow, and like we are trying to kind of speed up that future, like kind of then the progress to the future a bit.
And so does Metaflow use services or depend on services at the level of batch and step functions and things like that? Or is it only expecting kind of raw infrastructure at the cloud? Like at what layer is it interfacing to the cloud?
Good question. So we like we definitely believe on standing on the shoulders of giants. So I mean, we have taken the stance that we want to integrate with the best of the breed solutions that already exist, including things like AWS Batch. And the reason for that is quite simply not because these systems are perfect, but I mean, there's so much engineering work that goes into building even these lower layers. That I
Mhm.
mean, it's just a kind of a humble recognition that like if you want to run like big fleets of containers in the cloud, there are many nitty gritty details that you have to figure out. And I don't think that like anyone has resources to kind of build everything from scratch. So yeah, I mean, indeed, we integrate with batch like directly, like we don't go to EC2 directly. Now with Kubernetes, well, I mean, Kubernetes is an interesting story, of course, because it's kind of a like a slightly different kind of animal. But I mean, in many other cases, the orchestration is a good example that people always wonder about the DAG orchestration, and like if Metaflow is like Airflow or like a Prefect or Argo or Dexter or like what have you.
Mhm.
And again, like even with orchestrators, our point of view, I mean, this is like again like coming from like a very many battle scars, like when it comes to running hundreds of thousands of workflows, that building a robust workflow orchestrator is actually hard work, and like it takes a countless number of engineering hours. And instead of us like trying to claim that we are just building a new like a workflow orchestrator, like we want to integrate with whoever like kind of builds the best one. The
Mhm.
reason like why, for instance, like we like AWS step functions is that, well, AWS just like has a really good track record in keeping these services running. So if you just want to like a no hassle system that somebody else takes care of, I mean, that is like a reasonable solution. I mean, of course, there are others like Airflow is super popular. I mean, many good things about Airflow. Again, I mean, like requires a bit more kind of like hand holding, like if you want to run it at scale, and that's why there are other companies who provide that as a service. But we see that machine learning ultimately is kind of like a layer on top of all these like of all this foundational infrastructure. And I don't think fundamentally, let's say, machine learning needs a whole different kind of a compute layer, or like whole different kind of a data layer, or whole different kind of an orchestration layer. But then it needs to add layers on top of those things. So let's say when it comes to model monitoring, model versioning, of course, like everything related to feature engineering, these are complex topics that then like need to be layered on top of this foundational infrastructure stack.
Yeah, yeah. So is the implication then that Metaflow kind of is and will remain a AWS specific tool?
No, I think like especially like with Kubernetes, the idea is that like through Kubernetes you can run it with other clouds as well. Also,
That
as
doesn't
as
get you step functions though.
no, no, but I mean, for instance, like Argo helps there. So I mean, like if you have
Hmm.
Argo running on Kubernetes, then you have kind of this like kind of a quote unquote Kubernetes native ecosystem that you can
Hmm.
run like using different clouds. So that's kind of the direction where we are going. But ultimately, Metaflow is not specific to any. I mean, there like if you actually look at the code base, you will find that like there's a plugins directory, and under plugins there's AWS. I mean, like equally well there could be one for GCP or Azure
Okay.
or like whatever else. So, but of course, like a Netflix is 100% AWS, so we just happen to have a lot of operational experience with that.
What are the what are the elements of the book that you're most proud of in terms of things that you treated better than what you've seen out there?
Yeah, well, I mean, I definitely don't claim to know everything that exists out there, and I know that like over the past I don't know like 12 months, I have seen that like many new really exciting books have been written about this topic. I think that this,
Hmm.
you know, I see that what we are now seeing, like let's say with MLOps, is a big macro trend in the industry. So many companies are really trying to figure out what's the right way of doing this. And like
Yeah.
always, when these macro trends happen, there will be many different approaches, especially initially. And if you like, I always kind of draw the parallels to e-commerce and like kind of like the web stack overall. And if you think
Hmm.
about the web frameworks, 2003, 2005, 2010, there were like many different directions. Is it like, should you be using PHP? Should you be using Django? Should you be using Ruby on Rails? And I think that's amazing thing that like we have a many like a very smart people innovating like a different type of approaches, and then like
Yeah.
everybody learns from each other, and then like kind of over time we converge something that makes sense. So in that sense, what I'm trying to do with the book is of course like a coming like from the angle that I have seen working. I mean, I'm sure that it's not the only way. And like what I really kind of what I'm trying to convey with the book, what I really like is really try to kind of touch like all layers of the stack, since that's what I oftentimes see missing. That there are like amazing companies, amazing talks, amazing books about like a specific questions, let's say that like a deep learning models or feature engineering or model monitoring. But then always the question is that, okay, so like let's say like kind of if I just want to test this model at scale, how do I do this? Or like if I need to version my models, how do I do this? So I think it's useful to kind of at least like a cover touch like all these bases one by one. And then like I think like the book says, I mean like it's totally up to you like how you decide to solve each one of these layers. And I'm sure that like there are many different solutions like to each one of these things, and like more will appear over time. So but it's really like kind of having that like a systematic like a 3ds of the whole stack is something that I personally like find quite valuable, because then it allows you to start like thinking the whole thing systematically and not get overly confused about the whole landscape. And I know that like you have been of course like doing good work in like trying to map the landscape and trying to kind of
Hmm.
help people understand like how all these companies and different pieces of infrastructure fit together. So I think that there's still a lot of confusion about that in the air.
Yeah, absolutely. Thanks for the shout out to our solutions guide. We'll definitely be linking to that in the show notes. You raised this interesting point about convergence that kind of had my head spinning as you're speaking. Like, what have we converged to on the
Yeah,
web?
well, I mean, that's that. Well, I mean, I
you
think that
could
like we
say you could say JavaScript, but then that thing, there is a total divergence in terms of JavaScript frameworks and
Yeah, yeah. Well, I mean, like, I would say that like we have got rid of some things that maybe didn't work so well. I mean, like, I don't know how many people anymore like write CGI bins, so how many people install mod Perl. And I think that like what really
fair
makes a
enough.
big difference is the fact that if let's say like if let's say you are not a C coder, like if you don't know like a web server's HTTP, you can go to Squarespace, you can go to Shopify, and actually like without any coding skills you can actually set up an e-commerce store. And I think that that is really the fundamental qualitative change, that there like now we have probably 10 times more people who can actually start selling coffee or baby shoes or whatever online.
Yeah.
And like we are not yet at that point like with machine learning. I mean the fact is that if
Yeah,
you have
absolutely.
like a random company, you want to start applying machine learning, you want to hire a data scientist, and now you are thinking that, oh my gosh, how do we make this person productive? How do we actually allow them to study trading? I mean, you're still at pretty much at loss. That like, okay, so what kind of tooling? I mean, okay, here's a laptop, and like maybe you have a Jupyter notebook on the laptop, but I mean, what else? So I think that that's something that's going to take another 5 years to figure out.
Yeah, yeah. It's an interesting question. I wonder if it's less convergence and more like raising the level of abstraction. Like the CGI
Yeah.
bin was a pretty low level of abstraction, and now
hmm
we have all different kinds
Kubernetes
of
is pretty low
things.
level. I mean, look, I mean, there are still
Yeah.
companies who say that like data scientists should learn Kubernetes. It's like it's data science or like a web developers learning CGI bin or like kind of Apache config. I mean, honestly, I mean, most people don't care anymore. So yeah,
Yeah.
I mean, I mean, the fact is that like the progress is never linear. It's kind of funny that like oftentimes we take 2 steps forward and like occasionally like a 3 steps backward.
Uh-huh.
I remember like for instance like when MapReduce Hadoop was a big thing. I mean, people like were really interested in re-implementing all machine learning algorithms on top of the MapReduce paradigm, and
Yeah.
it's just like a mind-boggling exercise that it doesn't make much sense and everything becomes slower than what they used to be. And then like it turned out that that was a bit of an evolutionary dead end, and like then people like kind of came back, and now I mean we have a much more sensible approaches. But I mean, yeah, I mean it takes a bit of a brownian walk always to come to the good solutions.
Uh-huh. Uh-huh. Um kind of along those lines I don't know if it's along those lines, but when you think of like the persona that you're building Metaflow for, is it kind of this traditional data scientist that, wasn't kind of, their kind of sweet spot tool isn't Kubernetes or containers, but rather Jupyter notebooks and traditional Python tools?
Yeah. So the kind of the minimum height for this ride that we have always required is that well you kind of need to know some Python. So let's say that
Uh-huh.
like if you have been able to like go through scikit-learn tutorial in a Jupyter notebook, I mean then I think like you have a like good skill set that you can get going. Assuming that especially like kind of if there's someone like to maybe help to deploy the system. I know that let's say I mean when it comes to getting your AWS account set up, I mean, it requires that you go to the CloudFormation console, and there are many new concepts there, and that's it. But I mean,
Hmm.
once you have the system set up, then at least like if you are able to write Python code, I mean, you should get pretty far, and that's really the idea. And like another thing that I really strongly feel about is that you know as we all know, experimentation is really key to data science, and like the idea that you can like try even like crazy ideas is really really important for all machine learning data science projects. And now, what I have seen happening in practice is that many data scientists, especially those who don't necessarily have like a 10 years of experience, they are very hesitant to try out crazy things because they're afraid that they will break something. There might be and like an engineer yelling at them that look, I mean, you are allocating too much memory, or like kind of you are making your
Mm.
Docker file incorrectly, and that kind of makes them self-censor. It makes them self-limit like what they do, and they maybe stick with some paved path that okay, I mean, as long as I'm doing exactly this thing, I mean, then it's fine. And that
Hmm.
is, I think that it's quite detrimental like for data science projects, where it's very important that you are like able to try different tools, different approaches, like test freely. And like one really key idea what we have always had is that whatever the infrastructure does, it should work so that like the data scientists can't break anything, and there should be a strong isolation, let's say, between the production pipelines and the experimentation. That let's say if your company has a production ML pipeline, no matter what the data scientist does on their laptop, assuming that they are not actively malicious, which is usually not the case, they can break the production. And like if you ask this question like kind of from yourself at your own company, that is it so that you can run any piece of code on your laptop and like no matter what you do, like kind of it can't break production? Unfortunately, often, I mean, the answer is still no, that like there are commands, there are things that you can run that will break everything. And it's all those things that now imagine that you hire a new data scientist, a new employee at your company, you give them a laptop and you say that okay, so here are some things you can do, but I mean, please don't do that and don't do that, or otherwise like kind of all hell
Yeah.
breaks loose. And then of course, I mean, people become afraid, and that like really limits their productivity and creativity. So I think that this is really important part like of how we think about the persona as well, that kind of no matter like kind of what kind of background you have, like whether you are experienced, inexperienced, even for myself, I want to have that feeling that okay, I can do whatever, and like I can't like break things really bad. And I think that's really important, because then no matter like if you are like a 10-year-old, or like if you are like kind of if you have been doing this for a long time, we can just tell that okay, start tinkering, start trying. I mean, like Google stuff, like copy paste stuff from Stack Overflow, it might be totally crazy, or like use GitHub Copilot, and like what you get out, I mean, might be totally incorrect, but I mean, like at least you can't break anything. I think that's really important.
So one challenge that we see a lot is kind of folks scratching their own itch, building tools and platforms that solve a specific problem. Going out to doing it at scale as a commercial entity, and then realizing there's not just that core persona, the data scientist persona, but also there are, enterprise IT and security and all these other people that, either need or want to be involved at scale. Do you, to what extent are you catering to, and this is, of course, particularly true in ML ops, which has as, a bona fide part of the name ops.
Yeah.
To what extent are you, catering to that community, building tools for them, thinking about their requirements, and how does that show up in what you're doing?
Yeah, yeah, good question. Now, so the way I think about it is that as long as machine learning and data science was pretty much like a research activity, so you had R&D and like you had people doing development, you had people doing research. And like as long as it was only research, you could have these isolated environments that had nothing to do with production. They could have their own rules, their own whatever, like a crazy sandboxes, and like it wasn't like kind of that important that you actually interface with IT, interface with security. Now, I think that as companies really want to start employing ML in production, actually like to help the bottom line of the company to actually like drive revenue and so forth, the ML can't be a research activity anymore. It can't be an island. It can't be an like an isolated sandbox anymore. And this is actually like really, if you think about the really the long arc that what used to be the situation even 20 years ago, that like people were doing machine learning, let's say in MATLAB or Mathematica, or like if you think about tools like RStudio or even Excel, all these tools are actually like quite excellent in like quickly iterating. I mean, if you think about Mathematica that has had notebooks since 1980s or something crazy like that, that works fine. But the key problem that these tools had is that they were not compatible with production. Like if you had something running in Mathematica and like the company wanted to deploy this on their production infrastructure, there was simply no way. I mean, like you had to re-implement the whole thing from scratch. And now as we want to start using machine learning in production, like we really have to kind of break these barriers and get out of the sandbox. And I think that then it's absolutely inevitable that like the ML needs to kind of grow up and it needs to start complying like with these governance policies, with the security policies, with whatever like IT things you have. And now we are in this interesting kind of a conflict even, that like we want to iterate, like we want to experiment like with crazy things, and at the same time as things approach production, like we want to kind of like play nicely by all the kind of the rules of the production. So that is kind of the kind of the gap that we are trying to breach. And I think that the important thing is there also to do it gradually. And I think that too many companies still are thinking it as a black and white matter, that either you have something that's totally crazy, totally not production compatible, or then you have something that like 100% like kind of a all I's are dotted and all T's are crossed, like that takes a lot of effort. I think that like Netflix managed to do this really well. I mean, thanks to their experimentation culture. That let's say you have an A/B test and like you have a production model. Somebody builds a new model. Now, in order to test the new model in kind of actually like to get good read if it works, you have to deploy it to production and run an A/B test. Now, at the same time, the new experiment doesn't necessarily like have to be kind of as production ready as the kind of what's already deployed in production. And like there should be a path, there should be a way how you can like run these experiments easily so that they are good enough that like you dare to run them in production, you dare to expose the results to actual users. And at the same time, you don't want to impose so many restrictions and so many constraints that it takes 6 months to kind of get any experiment running. So I think that that's the kind of the interesting kind of the line that like many companies have to walk, that okay, so how do we think about like 100% production, how do we think about 10% production, how do we think about 50% production, and like what are the governance policies at each kind of a step on this journey. So but yes, I mean, I guess the kind of a very very short answer is that yes, like we should be thinking about all these like operational, but it's not black and white things.
Yeah, yeah. Awesome, awesome. Ville, just to kind of wrap up, any parting thoughts on where this is all going, both in terms of your work with Metaflow and Outerbounds, as well as MLOps in general?
Yeah, well, I mean, I think we are like living very exciting times. Like, I mean, kind of the
Uh-huh.
fact that
For
there's so
sure.
much activity in this space, so many companies. I'm always like a super delighted to talk to founders of different companies. It's always super fascinating to hear like how different people are approaching this. And with that, I'm pretty sure that like over next 5 years, like we will learn a lot. I think that there might be. It's hard to say if there's more fragmentation or convergence. I think that like some things converge, something probably will diverge a bit. So, but
Hmm.
that's going to be exciting. Now, also like on the kind of the user side, on the company side, what's also super interesting is that I meet people from all kinds of companies from all kinds of traditional industries that are now starting to apply ML, and I think that that's really
Yeah.
really encouraging. And I think what's really interesting is that it's the pandemic. I think really kind of a leapfrogged this development, that as there
Hmm.
was more pressure for all companies to go digital, like for all companies to go online, with that came the idea that, okay, we have to become smarter about our business. The competition is tougher. And more companies realized that, oh, I mean, like we actually should have a recommendation system on our website, or like we should be thinking about our logistics. So maybe we should be analyzing our churn and all that stuff. So more and more companies are starting to do this for real. And of course, I mean, still today it's not as easy as it should be. And like, of course, what we are trying to do is to try to make it easier. So definitely, I mean, I invite anybody like kind of who has any interesting ideas, want to chat. I mean, like reach out to me. So we have an open Slack at slack.outerbounds.co. I mean, like everybody's welcome to join. I mean, it's not only about Metaflow. If you happen to be using Metaflow, I mean, we are happy to help you there. But I mean, otherwise, like just like a happy to chat and share notes.
Awesome. Awesome. Well, Ville, thanks so much for taking the time to keep us updated as to what you're up to.
Yeah, thank you. Thanks for having me.